Everyone, welcome back to a new exciting case study. My name is Vijesh and today we are going to see a new case study using an exist operator. This one is one of my favorite case study, so let's get started. Before that, if anyone is interested in learning more about the SQL tuning course, please feel free to drop an email at helpdesk@verses.com, the details of which I have mentioned in the description. Also, don't forget to hit the subscribe button to stay tuned on all the latest updates. So let's get started. So this is a new SQL query. Select E dot first name, E dot last name, E dot hire date from employees E, departments D. That means it's a join operation between the two tables, employees and the departments. Where E dot employee ID I have provided 5 different employee IDs. And then there is an exist operator. And within an exist operator, there is a select as a subquery. Select job ID from jobs J, where J dot job ID is equal to E dot job ID, and E dot departments is equal to D dot departments. So this is the SQL query, and when I execute this query, I am getting 5 rows for all the 5 employee IDs. And this is the execution plan which Oracle has taken. So let's analyze this SQL statement first. So looking at the SQL text, we see that there is an exist operator here, and it has got a subquery. So before analyzing that, we need to understand what an exist operator is. Exist operator is something which checks the validity of a row value. That means a row value that is passed inside the exist operation here will be valid if the operation within the exist clause returns a value. If it doesn't return a value, then the row value which is passed inside this exist operator will be discarded. So that is the purpose of an exist operator. All right. Now let's have a look at this query. So exist operator can perform poorly in two conditions. Okay, so there are two conditions in which this exist query can perform poorly. So let's see what the first condition is. If all the row values of the outer table, that is nothing but your e.employee ID in this case, if all of these values is passed inside this exist operator, that many times this inner subquery or inner query within the exist operator will run, right? That means job ID will be tried to match with all the job IDs from the employees table. So this is going to take a tremendous amount of time based on the size of the employee table or based on the number of rows the employees table is having. So employees table is having around 107 rows. This means that in this case, if all of my employee IDs are going inside the exist operator to check its validity, job ID is equal to will be executed 107 times, right? So that is the one case in which the exist operator is going to perform poorly. Second condition is if this exist query itself execute first, that means the job J table has to be accessed first. That means for the jobs table, J.job ID, all the job ID has to be scanned because job ID is part of the where clause. So in this case, all the job ID has to be scanned using an index full scan, and this is again going to take a lot of time. So once the job ID, all the job IDs are scanned, the filter operation or the access operation on the employees table will take place. It will access only these 5 employees, and only these 5 employees will be passed inside the exist clause, so that wherever this condition is matching, those rows will get qualified. So in this case as well, if I execute exist operator first based on the jobs J on using an index full scan on the job ID, it is again going to take a lot of time, right? So this is something which we have to avoid. This concludes that we shouldn't be starting with the exist operator first. Anything within the exist operator, we shouldn't be starting it first because that is going to take a lot of time in both the cases. Either executing the outer table first or either accessing the outer table first or either executing the query within the exist operator itself. So in both the cases, it is going to take time. So our approach should be execute the exist operator as a second operation or the later, but not the first, right? We should be executing the other part of the where clause first and then the exist later. The minimum is second operation. That means exist should be executed as a second operation or the later, but not the first. So that is the ultimate purpose by which we can tune a query in a much faster way when you are having a exist operator in the query. So let's see how we want Oracle to execute this query. So looking at this query, let's go back to again to the basic fundamental approach. We have to start with such a column in the where part of the clause which is going to give me very less number of rows. So in this case, obviously I have to start, or I have to first access my employees table using the employee ID column. And since I have an index and employee ID is a primary key, this 5 employee IDs is going to give me only 5 rows, right? So I will be starting with this e.employee ID in this many rows. So I'm getting 5 rows. These 5 rows will go inside the exist operator, or also it can go directly with the join operations on the d.department ID, because department's ID in the department table is primary key. This join operation is again going to give me back my 5 rows. Okay, not more than 5. It's again going to give me 5 rows. Now these 5 rows can go inside this exist operation, so that this within the exist operator can be executed. Now looking at this exist operator query, select job ID from jobs, where j.job ID is equal to e.job ID. So in order to execute this query, I have to know the job ID of the employees table for those employees whichever has been accessed. So in this case, these are my 5 employee ID I have accessed. For all these 5 employees, the job IDs will be fetched for those employees, and one by one it will be passed inside this subquery, and it will be executed 5 times. And if this operation, or if this subquery returns a value, that employee ID will be retained. If this operation doesn't return a value for a specific row value, that means a specific job ID, then that row value will be discarded, right? So this is the way in which we want Oracle to execute this query. First, we will be accessing the e.employee ID in, which will give me 5 rows. This 5 rows will go with the join operation with the d.department ID. Again, it is going to give me my 5 rows, and this 5 rows should go inside the exist operator to check for its validity, whether that value exists or not when I pass that value inside this subquery. So this is the order of operation. Now let's see whether Oracle has executed it. So when I execute this query, I'm seeing 5 rows. However, if you see the execution plan, there are some 19 rows which I'm expecting, right, for the job ID PK. So this means that there's something wrong which the Oracle has done, and this is not the way which we want the Oracle to do. Okay. Now looking at this execution plan, if you create a parent-child relationship, fourth operation is the first because it is the innermost. Then the third will execute because it is the parent of 4. And now since 3 and 5 are on the same line, 5 will execute after third. But in order to execute my 5, 6 has to execute because 6 is the child of 5. And before 6 has to complete, 7 should execute because 7 is the child of 6. So the order of operation in this case will be 4, then 3, then 7, then 6, then 5, then this hash join on operation 2, then 8, and then 2, right? So this is the parent-child relationship. So like we deduced, fourth operation is something which is going to execute first. The fourth operation is an index full scan on the job ID column for the jobs table. So like I said, it is actually executing this part of the exist operator. That means it is accessing all the job IDs for the jobs table. Then it is accessing this e.employee is equal to 101 to 105. So once all the job IDs are scanned, this 5 employees will be scanned, and these 5 employees will be passed inside this subquery to check its validity. So this is a lengthy operation. So for example, if the jobs table was very big, say it has got 1 million of rows, then obviously this approach is going to take a lot of time, right? We didn't want Oracle to execute exist operator first. So what we have to do, it's very simple. We just have to start this query execution with the employees table rather than the jobs table first. So very simple, we'll just pass a simple hint that is nothing but your leading E, which will tell Oracle to start with employee ID column of the employees table. So before we start, let's see some table statistics. Like I have used the same table statistics as part of my previous case study. So employees table is having 107 rows. Employee ID is the primary key in this table. So again, it is having 107 distinct values. Again, in the departments table, I am having department ID is the primary key, which is having 27 distinct values, and the total number of rows in the departments table is also 27. So I mentioned this resolution over here, and I have also attached this case study in a link, which is again present in the description. So let's see the resolution. Like I said, we have just passed a simple hint that is nothing but your leading E, which will tell Oracle to start with the employees table. So this, all the employee IDs will be accessed. The specific job ID for those employees will be accessed using the table access by index row ID. and each of those job IDs will be verified against this subquery to see whether those job IDs actually exist in the jobs table or not. So in this case, all the job IDs for those employees are present. So that's why those job IDs became valid, and that's why automatically those employee ID also became valid. So that's why after executing this, I'm getting all the details for all my 5 employees. So let's see the execution plan for the same. And if you make a parent-child relationship, fourth is the first operation, and it is accessing the employee IDs 5 rows, right? So it is accessing the e.employee ID is equal to 101 to 105, right? And then it is doing a nested loop join operation with the d.department ID is equal to d.department ID, right? So if you see, you don't see that the table jobs is being accessed here at all, right? It is not being accessed at all. The reason why is because if you see the DDL for the employees table, you see that the job ID is a foreign key in the employees table, right? And the parent table for the job ID is jobs table. So this means that for the employee IDs, there is a specific job ID, right? And since this job ID is a foreign key in the employees table, it is definitely going to be present in the jobs table as well, right? So that is the reason why this part of the select query is not at all executed, because whatever job ID is present in the employees table, that obviously has to be present inside the jobs table as well, because the job ID is the foreign key in employee ID for the parent table jobs, right? This execution plan has helped to faster the execution by accessing only the 5 rows of the employees, then checking the exist clause validity. In this case, it is not needed. Even though it was needed, it would have executed perfectly fine, because we are passing only 5 rows inside the exist operator, right? So the goal is achieved. We have to pass less number of rows inside the exist operator to execute the query in a much faster way. So that was about the case study for today using an exist operator. Hope you liked it, and please feel free to share the comments. If there are any doubts, please feel free to comment below, and please subscribe my video. Thank you so much.